Hey, and welcome back to the Horsepower Monster. Got a good one for you today. You often hear people make their own theories about flat tappet versus roller cams and how they vary in power and everything, but you rarely get to see it tested because that's a lot of engine you got to change out to do back-to-backs. But thanks to Keith Newcomer at Newcomer Racing, we're going to do exactly that and bring you the results. Now, if you've watched the Horsepower Monster before, you're probably familiar with some of the videos we've done with Keith. He specializes in straight six Jeep engines and does a fantastic job of making power out of those babies. Now, Jeeps were made for decades and they all came with flat tappet lifters. And that's fine if you're doing low power, long lasting engines, but if you're trying to make more power, more spring pressure, more aggressive load lift, a flat tappet is gonna be a problem. So roller lifters are the way to go. They've been tried before, but they've always failed. Keith is doing his own version here with some really high quality product, and if anybody can make it work, he can. I'm gonna bring you that and show you everything behind the scenes. But first, if you wouldn't mind, give me a like and a subscribe. It really helps the channel with the algorithm, and I certainly would appreciate it. Anyhow, enough talk, let's get on with it. We're back in the dyno with Newcomer Racing, but it's a big deal today. Tell us why, Keith.
We're going to do a cam swap, and we're going from a solid flat tappet to a hydraulic billet roller. This is going to be like a really good back-to-back test, so it's going to be basically the same grind, the same numbers, just in a hydraulic roller version. And we want to see just how it's going to compare. You know, I know the solid flat tappet really winds up high. You know, the hydraulic roller may not wind as high, but I'm expecting it to be more broad. Biggest thing is durability, and we've kind of already proved that somewhat. So now we're just going to beat on the dyno and see what the actual differences are in power.
Now Keith is being a little bit humble here because this is actually one of the only roller setups that you can put in a 6-cylinder AMC Jeep motor, right?
Yeah, this is it. Like this is what you want. I mean, I'm not trying to promote this. It's just, it is what it is. There's been tries at this in the past. It's not been successful. You know, most of the time it's based off of a cast core and the lobes wear out. It's not been good. This is OEM spec quality, really nice stuff.
So if you want a modern technology roller cam in your Jeep motor, it's basically Newcomer Racing or nothing, right?
At this point, yep.
And maybe the best part is we aren't just dynoing a fresh build. We're actually testing Newcomer's new roller valvetrain against a basically identical working setup. This is a pretty stout 4.7 liter stroker motor that Newcomer uses for testing different ideas.
This is it. This is our test mule. I beat on it all the time. It's been in so many different forms, but I thought that one of the cams we have is really, really close to the same cam that's in this. I know this cam is probably trying to wipe a few lobes also, so why not? Let's just pull it out. Let's do the conversion on this one and see how it does. And then we have tons of data on this motor exactly. And so what we're going to do is pull it out, take it over, stick it on the dyno it, tear it all down, show you the conversion, take it back to the dyno and see what the difference is.
Okay, so tell us about our dyno mule, what we're running today.
So this is the Mutt motor, and the Mutt motor has been around for quite a few years, and we've tried so many combinations. It started life as just a refresh on a 4-liter, and then we decided to throw a turbo at it, and we've made over 500 wheel horsepower with a turbo. And then we decided finally we were going to stroke it, ran a naturally aspirated for a while. We went back to a turbo again, made more power. And then I've put it in my Jeep and I've ran it. It's probably got 15,000 miles on it. Probably not the easiest miles. So we're trying to figure out a good platform to do a cam swap on. Something we can get some mileage on too. And why not use the one we've tested everything on? So The latest one is we put an Edelbrock head on this just to kind of see the difference versus a stock ported iron head. And there's nothing different with this block. It's just like any other block, any other motor. So what we're going to do is tear it apart, take out the flat tappet cam, and we're going to put a hydraulic roller in it, and we're going to show you what it takes to convert it.
It has 60 over cylinder bores and a fully counterweighted crank from a 4.2 engine for 3.895 inches of stroke. Those are Newcomer's own reusable copper gasket to seal the intake and the exhaust, and the aluminum cylinder head is a hand-ported casting from Edelbrock. And even though it's still working great, Keith says it's got somewhere around 15,000 miles on it. So that's where we are. We've got everything we need to run the built motor as is, and then a full table of components to change everything over to Newcomer's new roller setup right in the dyno, including, and this is important, a new roller cam with matching specs for the flat tappet. If you recognize the dyno cell, that's because we're at Automotive Specialist for this test, and that's AutoSpec's own Justin Bryson lending a hand. So let's make a baseline pull. This is with a hand-ported cast Clifford intake manifold, which so far has been about the best thing out there when it came to performance for naturally aspirated Jeep motors. That's important, and I'll get to it in just a second. In this configuration, our 4.7 liter stroker motor made 342.6 foot-pounds of torque at 5,200 RPM and 368.5 horsepower at 6,300. That's already quite impressive considering in stock form the Jeep motor is usually worth about 175 horsepower and 190 at best in high-performance trims. Anyhow, I know this video is about Newcomer Racing's really cool roller cam setup development, but let me just veer off for just a second because this really shocked me and it's just too cool to leave out. I know you're gonna love this. Keith wanted to make a couple quick dyno pulls to test a new hand-fabricated intake manifold design he'd come up with while we had this well-worn engine on the dyno. I didn't think much of it at the time because for years the Clifford style intake has been proven to be the cream of the crop. So I just didn't think we'd see much difference. But it's really hard to do any better for the Jeep Straight 6. And this one we're running, Keith has already done some really aggressive hand port work to absolutely max it out. So Keith bolted up this fully fabricated unit. Now, I need to let you know that this is an R&D unit that he's asked me not to show too much of quite yet, but I can say it's designed to provide maximum signal to the carburetor at all 6 runners. Hint, hint. And here's the dyno pull. Honestly, the results shocked everyone in the room. I know Keith had his suspicions that it would work well, but usually when you're talking about intake manifolds on these engines, the improvements are in 1s and 2s. not gains of 25.4 foot-pounds of torque. Peak horsepower didn't improve, but this manifold did see gains in terms of the averages across the pull of 18.4 in the torque category and 14.1 horsepower. And the biggest torque gains were low in the RPM range, as you can see here, exactly where it will be the most useful to Jeepers. This thing is big time. So, obviously, we left that intake on for the rest of our testing. I'd love to show you more when it comes to this intake, but Keith would like to keep the specifics under his hat for now while he irons out the final details and works out the process of turning this into a durable casting for sale. I'll put a link to Newcomer Racing in the description, and I'm sure he'll have more information soon as it's ready on this bad boy. Now we can get back to the task at hand. A cam swap in a straight six is no simple task, but thanks to the magic of cinema, which is also known as the time-lapse setting on my GoPro, it won't take but a second. Keith and Devin Rao pull the intake and exhaust, the rocker arms, and the cylinder head so that they can get to the lifters. So, every Jeep straight six right now has to run flat tappet lifters like these. Keith has done what he can by going with a performance aftermarket set of lightweight, solid flat tappets with EDM holding holes in the lifter faces that injects oil between the lifter and the cam lobe. But there were still signs of a looming failure. That's just a well-known fact of life when you're running flat tappets in any type of engine with big cams and high spring pressures. Anyhow, so once those are out of the way, we can pull the original camshaft. This is a cast cam which works for flat tappets, but it won't last too long on an aggressive roller cam. So the Newcomer designs feature super strong billet steel cores.
So these are basically the same specs. We have a flat tappet version there, and then we have a roller version here. You can definitely see the load profile difference of the two.
Yeah, much more.
But as you can see, on the flat tappet we had, like it was already starting to eat a lobe, like there. Right here was another one. This is, like here, this is definitely flat, that whole area there.
So this is not just a performance thing we're doing. This is longevity and noise, vibration, harshness, and everything.
Everything. So, I mean, it would all be nice, but longevity is the whole thing, because if we can take that factor out of these motors, I mean, there's very few other things that are going to go bad on these. This is the main thing. So if we alleviate this and the longevity is there, I don't even care if it makes more power, just as long as it lasts a long time.
When Keith talks about a flattened lobe, he obviously doesn't mean that the entire lobe has been ground down and just wiped off. There's still enough camshaft lobe to open the valve, but the crown of the lobe has been ground flat. It's this crown where one side of the lobe is just a bit higher than the other, and that causes the lifter to spin in its bore. When that crown is gone and can no longer spin the lifter, it's a slow but certain death for the valve train. So now, let's take a closer look at the new roller cam that we'll be installing.
This is performance. So this is an NR 128. It starts. Our part numbers start out at like NR 119. That would be a stock high output cam. This is kind of the middle of the road cam. This is for a boosted application or naturally aspirated, but it's a single pattern, 228, 228 on a 113. And this motor goes back between boosted and not boosted. So this is a great cam for it. And it's got excellent drivability, good low end, as you can see in the dyno curve, top end also. So we'll see what this one does. Hopefully it'll be a little even better.
With the new camshaft in place, we can turn our attention to the new roller lifters. This is a custom set Newcomer Racing has been working on, and I have to stress that it is still in development. So the final product may be a bit different. The most obvious difference is one side of the tie bar is slotted so that the two lifters aren't permanently tied together. And here's why our normally married lifters have to be temporarily divorced for installation. The Jeep casting design puts a big divider between each pair of lifters. It's impossible to get them in place with them permanently paired together. So the lifter with the tie bar still attached goes gently into its home, and then Keith uses a magnet to lift the tie bar up as far as possible and then delicately slip the second lifter into its spot. Believe me, I was pretty annoying trying to jam my camera in there to get shots while he was doing this. Missed it? Don't worry, we've got to do it all over 5 more times. But before we do that, Keith needs to use that first pair of lifters to help degree in the cam and make sure everything is set up basically the same as it was with the flat Tappet valve train. You'll also notice that the link bar has been dog boned right in the top center, so now it looks a bit like a sway-backed horse. And some of the rivets on the bars have also been relieved on one side. Only 2 of these rivets need to be relieved like this, and that's for cylinders number 3 and 4 because of this dent in the center of the casting. Now, it's possible that this can be solved by doing a Z-bar style lifter that spins the attachment point to the other side, but when we shot this, Keith was still sciencing out those issues. So that still remains to be seen. The dip in the top of the tie bars is because if you don't, it'll hit this support cast into the lifter area when either of the lifters are raised up by the cam. Now, the problem is these block castings were produced for several decades, and as you probably already suspect, there's a lot of variation going on from block to block. So that means there's a delicate balancing act between making the scoop in the top of the link bar big enough to clear every block out there and going a bit too far, and well, we all know what happens when you go a bit too far. But eventually, Keith got all 12 lifters in there with the tie bars properly attached, and he and Devin could continue with the reassembly. We use the same valve springs for both tests. These are lightweight beehive springs from Comp Cams, part number 26915. Now these are really popular springs with LS builds with a rate of 313 pounds per inch. Newcomer plans to have some entry-level roller cams ground that'll work with the stock springs, but if you get very aggressive, you'll likely need to upgrade to something like these. Now I couldn't find anything in my notes, but I'm about 98% certain there was a change in the lifter height that required a new set of push rods from what we used before.
I was about to put it in a motor. I'm like, let me just check all these.
Now don't let me mislead you on this cam swap. This isn't exactly an easy or a cheap thing to do. For example, these lifters require between 10 to 15 thousandths of an inch of preload. That's a pretty exact amount, and it's impossible to get that with stock rockers and be sure you've nailed it. Instead, you'll need something with a pushrod adjuster cup like these custom Newcomer Racing roller rockers. But then, the roller rockers are taller than stock, so you'll also have to have a valve cover spacer. When you put on a valve cover spacer, that requires a special thermostat housing so everything will still fit. You get the idea. This stuff just adds up. But if the cam works as advertised, it'll be worth it. Oh, and there's one other change you need to make. Keith, you had to make a quick change to the distributor here for our roller system. Now, why is that?
Yeah, because this gear, if you would run like a regular steel gear, it's just going to wipe the gear out. A lot of people would go with like a bronze gear or something, and that's going to wear out fast too. But for street use, you're going to need a melanized gear, and this is in pretty much all factory style vehicles like old Vortec 350s that would run 300,000 miles no sweat. Same type of gear. So the melanized version, that's going to go in here to mesh with the billet roller.
Was that something you had to come up with, or did they make those?
Yep. These are all one-offs. So this is for 500 shaft for MSD, anything aftermarket, and then the 531 will be for all factory style distributors. Yeah.
Perfect. But that's about it. Then Keith and Devin were able to finish buttoning everything up, and we could make our first pulls with the new roller cam. And just like with the fabricated R&D intake manifold, the results of the roller cam swap were honestly shocking. You heard Keith say that he was mainly looking for improved reliability, but the reduced friction from the roller lifters made a real difference. Torque jumped a whopping 12.4 from 368 to 380.4, and horsepower also went from 365.9 to 373.4, an improvement of 7.5 horses. And we also gained area under the curve. Across the full pull, the average torque increased by 9 foot-pounds and average horsepower improved by 7.6. We were also worried that the heavier hydraulic roller lifters would limit production in the upper RPM range, but valve control remained steady all the way to our self-imposed 6,500 RPM redline. And the power levels were basically the same all the way at the top of the pull. And best of all, there were no mystery sounds coming from inside the engine, and everything worked exactly as it should. Okay, Keith, we've had 2 days on the dyno and some pretty surprising results with the intake manifold, but what all have we learned?
We learned that we like billet rollers. I'll tell you that. Like it is a pain. Like you need a bunch of little tools, and you need even more patience. But once it's done, like, it's really nice. I mean, we rev the crap out of this, and it doesn't care. And we're comparing that to a solid flat Tappet, so I'm totally impressed. There's no bad to this at all. Like, no bad from durability, horsepower, torque is amazing. So I'm good.
Power was a surprise, but you're expecting big gains in longevity, which we can't even tell yet.
Correct. Yes. Everything looked great. I mean, the few swaps we've done already have looked great. So I don't have any doubts at this point.
The next step is for Keith to put this engine into one of his Cherokees and give the engine some road miles. Hey, thanks again for watching the Horsepower Monster. Leave a comment and let us know if you think this swap is worth the hassle, and we'll see you next time for another great engine. Take care.